Let's take a look at the cell customer class we designed in the previous video, and we'll try implementing that in C#. We'll also create a driver class to test it out. If you haven't watched that previous video, it's really quick and you should probably take a look at that before you go on with this one. To begin, I've created a project with top-level statements as usual. I'm using Visual Studio here, but it will be similar in other IDEs. As a best practice, I want to create a new file for my class. I'll go over to my Solution Explorer or File View and right-click on the project name. I need to be careful that I'm hitting the project and not the solution. From this menu, I'll go to Add and then click Class. For a file name, the best practice is to use the same exact name as the class you'll be creating. So I'll put in Cell Customer with capital C's. Leave the .cs extension there so it can be identified as a C# file. The IDE will create the new file and we'll probably put in some basic code to get us started. We won't worry about this top section with the using statements for now, but I do need to put in my comment block using whatever format the assignment or your boss requires. Next up is a namespace statement, which helps us organize our code and avoid problems with duplicate names. For example, Ed Sheeran recorded a song called Galway Girl in 2017, but there was already a perfectly good song called Galway Girl by a guy named Steve Earle about 15 years before that. We could put those songs in different namespaces to avoid getting confused. Steve Earle.Galway Girl would refer to the good song with that name, and Ed Sheeran.Galway Girl would refer to the one that should have had a more original name. In general, we just use the name of the solution as our namespace, and your class goes inside of that. And that leads us to our actual class statement, which is internal class cell customer. The internal part means that we can only use it inside this project, which is fine for now. Later on, we'll replace that with the word public. We'll organize our code in the same way as our class diagram, so we'll declare our fields right up at the top. Each one should be private, and I'm just looking at the class diagram to see what I have designed. These are really just variable declarations with the keyword private to keep them encapsulated. Next up is our accessors or getters. As a new programmer, you should just get in the habit of making a getter for each field, and these just follow a basic pattern. It has to be public because the point is to give access. The method return type will be the same as the field's data type. So this is for the name field, which is a string, and the identifier is the word get plus the field name, so get name. The parentheses will be empty. There are no parameters for getters. Just like any other method, we'll need a code block to put our lines of code in. A basic getter has only one line of code, the word return and the field. Now, I encourage the habit of using dot notation with all field references. I'm going to put this dot name. The this keyword refers to the current object. We don't have to put this dot, it'll still work if we just put name. The idea here is to get us used to that dot notation, which we're going to need elsewhere. It's a good habit because we're going to see some situations where this dot actually is necessary. And also, it's just a good reminder that we're looking at a field rather than a regular local variable. Now, having said that, there are plenty of coders who only use this dot when it's necessary. So this isn't a convention that's universal, and I try to be a little realistic about that, and I don't require it. And that's actually all there is to a getter. Since I have 4 fields, I'm going to have 4 getter methods. So I'll just use the same pattern to create the other 3. The next few methods on our class diagram are the set methods. Our setters will get much more interesting as we learn a little more, but for now they are also going to just follow a simple pattern. A set method has to be public. For now, you should be making all your fields private and your methods public. As usual, we'll eventually see some exceptions, but that is how we implement encapsulation on a basic level. We're hiding the fields and only giving access to them through public methods. So the recipe here starts with public and then void. Setters don't return anything. Their job is to set a value. The name of the method is set plus the field. So in this case, set name. And in order to set a value for the field, we need to know what value we're setting. We'll need a parameter for that. The data type of the parameter matches the field. So for the name field, it's a string, and the parameter name can be anything, but I'm going to use CNAME, which is short for customer name. I'm intentionally not calling it just name because I don't want confusion with my field, which is also called name. Like a getter, a setter has one line of code. It's going to be an assignment statement. I'm just setting the value of this .name to the parameter value, so CNAME. And just like our getters, this is just a pattern, and we'll repeat it for phone number and monthly data. My last setter would be for remaining data, but before I do that, I'm going to stop and think. I'm not really sure I need a setter for that. I'm assuming here that we're using this method to initialize the data plan when the account is first created, so they won't have used any data yet. That means instead of writing a whole other set method, I'm just going to have this set method do both of those values. There's really nothing wrong with making a separate setter for the remaining data, but I wanted to point out that we don't always need a setter for each field. We are not really finished with this class just yet, but as a rule, I don't like to go a long time without testing my code, and that's especially true for beginners. So we're going to pause here and turn our attention to something we call a driver class. This is another one of those topics that frustrates some students. The sell customer class is what I would call an object class, meaning its purpose is to get used to make objects. It's not a program in and of itself. We're going to have a completely separate file with the program that uses our class. And we're not going to just start writing top-level statements or stick a main method in this file. That really seems to bug people, but we're going to keep them separate. The bigger potential frustration is that an object class like this one should not have any user interface elements. By that I mean no write or write-line statements, no read-line statements, no pop-up windows or boxes, nothing like that. That stuff is all part of the program itself, which goes in what we call a driver class. The analogy I like to use for this idea is the employees that are in a restaurant, where roles are very strictly defined and separated. In fact, they're separated so much that the food service industry has a pair of expressions for this: front of house and back of house. The front of house staff are the ones who interact with customers like servers and bartenders, and the back of house staff are the ones who prepare the food. The front of house staff don't cook, and the back of house staff don't get to talk to customers. And that's how we're going to treat our object classes and the driver classes. The object class is the back of house, and it never interacts with the user. The driver class is the front of house that deals with the user and uses the object class as necessary. Despite how frustrating this separation can be for some people, it's a good habit to get into. It's going to make our code more modular, easier to maintain, and it's also going to make it easier to test our code. It's another case of a best practice that I do enforce in my courses. So the bottom line is that we're going to create a separate class that will have a main method, and that's where we'll test our object class. The driver class will have any input and output that we need. Incidentally, we're really not making a program out of this, we're just focusing on the design of an object class. So my driver class isn't really much of a program, its job is just to test or demonstrate the object class. For that reason, you'll often hear me refer to the driver class as a demo class or a test class, and I sometimes name programs with that in mind. Since we're just demonstrating the class, this program isn't even going to have any user input. It's just going to run, and that's pretty common on my assignments. Okay, so the idea here is to have a program that is separate from our class. We actually already have another program because the IDE created program.cs when I created the project. I just didn't do anything with it. We made a new class right away. But we're going to use that and make that our driver. I can delete the template code that Visual Studio put there, and I'm going to right-click and rename the file to cellcustomerdemo.cs. Again, the idea is that the name is very explanatory about what the purpose of this program is. As I always do, I'll start with a comment block to identify the purpose of the class. And that's really all I need to do to get this program ready because we're using top-level statements. If I'm not using top-level statements, I'll have a namespace and class, and within the class I would have to put a main method. We'll see examples of that in other videos. I'll start by declaring a variable of type cellCustomer, and I'll call it customer1. Now this is no different than declaring any other variable like we've done to this point, but the data type is the class that I created. Visual Studio has recognized that my class is in the OOP demo namespace, so it added a using statement so the compiler knows where to find it. I actually made a small change that I forgot to record, so my namespace is probably a little different than yours. I think yours might be called cellCustomer, but this using statement is going to match whatever the namespace statement is at the top of that class file. And just like our other variables, I need an assignment statement to make it useful, but the assignment statement will look a little different when I'm instantiating an object. I'm going to use the new keyword followed by the class name and then parentheses. This is a constructor call, and it's going to create a new object using the class as a blueprint. We'll look at constructors in an upcoming video. But for now, those two lines of code give me an instance of the cellCustomer class. I should run this program to make sure it's working, but this code won't produce any output. I'll need a write or writeLine statement to show what's going on. I'll start with a writeLine statement that just outputs the object variable, and we'll run that. We do get some output, but it's not very useful. The output here is the name of the namespace and the class, and again, your namespace is probably different than mine. We've asked it to output the whole object, and this is what C# does by default. What I really want to do is output some of the fields in the class. So let's start with remaining data. I'll try to just reference that with dot notation. But it doesn't let me refer directly to remaining data because we've encapsulated that like we're supposed to do. To get that information, I'll need to use the getRemainingData method. Let's run that and see what we get. Okay, so I got a 0, which is what I expected. I haven't put any values for the fields, so they're all at their default values, which is a 0 for a numeric field. Let's do the same thing for the customer's name using the getName method. It just output a blank line for the name. The default value of a string is what we call an empty string, so that's what we're seeing here. To get values into both of those fields, we need to use our setters. I'll make sure I'm doing this above the writeLine statements, and now we'll use that dot notation to call customer1.setName. And since this setter needs an argument, I'll need to provide a name. Okay, it looks like my setName and getName methods both work. The last confirmation I'll need about those fields is that they are actually scoped to the object and they're not shared among multiple objects. So I'll need to come back up here and make another cell customer object, which I'll call cell customer 2. This time I'll combine the declaration and assignment into one line, just like we often do with other variables. And I'll call the setName method on customer 2 and pass in a different name. And I'll add another write-line statement to display the name of customer 2. Now I've confirmed that the name field and the method that goes with it are working correctly, so I'll need to do the same with the other fields and those methods. I'll use the setters to set values for the phone number and monthly data. Remember that setMonthlyValue method also sets the remaining data field, so I don't need to do that one separately. And I'll need write-line statements to output all those. I'll draw a little line here to just kind of separate out the different statements I have. Let's run this and see if it's working. And it is working. I've got all my fields set and I'm able to get that information back out, so I'm confident that my object class is working as designed and that the objects aren't interfering with one another. Now we can go back over to that object class and finish up the remaining methods that I didn't get to. These last few methods are what I would call mutators. They don't just directly set a value like our setters do, but they do end up changing the object's data, and mutate means change. First up is a method we can call when the customer uses some of their cell phone data. It's public, so we can actually use it, and it's void because I'm not asking for any information back. We're just going to reduce the amount of data the customer has left. We could write a method that reduces the value of the field and then also returns how much is left after we make that change, for example, and that might actually be a really good way to write this, but for the sake of our beginners, I'm trying to keep things really clear and simple by just having a void return type on this method. Our parameter is just the amount of data that the customer has used. The body of this one is pretty straightforward. I'm just going to subtract the amount from the remaining data, and that's it. Let's jump back over to our driver class and test this new method. I'm going to add a call to use data for customer 1, and I'll pass in a number. And then I need to output the remaining data to see if it's changed. I want to output both before and after the change. I'll run that and see if it's working. And at this point, we're almost finished. The last two methods are really similar to each other. The idea is that there are two ways for the customer to increase their data. They can buy more, which is the add data method, or they can have their plan reset at the beginning of the month, which is the reset data method. We'll start with add data. This is the same as use data, but it adds instead of subtracts. And since this was a really simple change to our code, I'm just going to go ahead and work on the other method before we do any testing. Reset data doesn't really add to the remaining data, it just sets it to the monthly data amount. So this one is public void with no parameters, since the amount it gets topped up to is the monthly data, and we have that number stored in a field. So the body just sets remaining data to monthly data. And now let's go ahead and test both of those. I'll call reset data down here at the end, and then I'll output what the value is after that. And I need to add data, so I'll just do that up here right after we used some data. All that output is exactly what I expected, so I really do think that's about it for this class. We've got all of our fields, getters and setters, and our mutator methods. We've tested all of our methods in our driver class, which we've kept separate, and we're confident that our class is working the way that it's supposed to work. As I mentioned earlier, this program isn't really much of a program, doesn't have user input or anything like that. And this is often what I ask you to do on my course assignments, where I want the focus to be on the object class, not the program itself. We still have a few important topics to look at with basic classes and objects, but this gets us started with the basics of object-oriented programming. I'll call reset data down here at the end, and then I'll output what the value is after that. And I need to add data, so I'll just do that up here right after we used some data. All that output is exactly what I expected, so I really do think that's about it for this class. We've got all of our fields, getters and setters, and our mutator methods. We've tested all of our methods in our driver class, which we've kept separate, and we're confident that our class is working the way that it's supposed to work. As I mentioned earlier, this program isn't really much of a program, doesn't have user input or anything like that. And this is often what I ask you to do on my course assignments, where I want the focus to be on the object class, not the program itself. We still have a few important topics to look at with basic classes and objects, but this gets us started with the basics of object-oriented programming. I'll call reset data down here at the end, and then I'll output what the value is after that. And I need to add data, so I'll just do that up here right after we used some data. All that output is exactly what I expected, so I really do think that's about it for this class. We've got all of our fields, getters and setters, and our mutator methods. We've tested all of our methods in our driver class, which we've kept separate, and we're confident that our class is working the way that it's supposed to work. As I mentioned earlier, this program isn't really much of a program, doesn't have user input or anything like that. And this is often what I ask you to do on my course assignments, where I want the focus to be on the object class, not the program itself. We still have a few important topics to look at with basic classes and objects, but this gets us started with the basics of object-oriented programming.